Yes.
Okay, so good luck. Okay, so hi everyone. Good morning, good afternoon, and welcome to the Dark Web and Tor webinar today. We're happy to have Dror Kernan with us, Senior DPI Researcher, and my name is Orna Sadan, and I'm leading the product marketing for the Enterprise Business Unit at Allot. I'm replacing today Mr. Ami Barayev, who unfortunately is with COVID since the last 2 days, so I want to wish Ami to get well soon, and I want to wish all of you to stay safe, safe and healthy. Before we'll start, just from managing this webinar, we'll leave enough time at the end of the webinar for questions and answers, and you are more than invited to write your questions in the Q&A chat box at the bottom of the screen. So what we'll do today, Dror will introduce the Tor, what is Tor, then we'll speak about how it works, what is the dark web, and what is censorship circumvention. And then at the last part of the webinar, we'll provide some introduction to Allot, and we'll see how the DPI technology, how Allot DPI technology really helps organizations to successfully cope with all the challenges that the Tor and the dark web bring with them. As I said, we are very happy to host today Dror Kernan. Dror is a senior DPI researcher in Allot. Dror previously served in the IDF in the leading 8200 unit. He's currently around 2 years in Allot and brings with him vast experience in DPI, VPNs, and the high-tech industry in Israel. And my name is Orna Sadan. I'm leading the marketing for the Enterprise Business Unit in Allot. I'm already a bit more than 2 years at Allot, and with a vast experience as well at the Israeli tech, high tech. And Dror, the stage is yours. Good luck.
Thank you very much, Orna. As Orna said, I'm going to talk with you guys about what is Tor, a brief overview of it, how does it work, the main concept, technological concept in it, what is the dark web, and all these terms you may have heard and never really understood what they actually mean, and how Tor aids in censorship circumvention. And then we'll and then we continue. So before we talk about Tor, let's talk about the purpose. Why do you even need Tor? What is it? Tor is a browser that's designed to provide its users with anonymous communication online. When we say anonymous, that's the idea of separating the user from the content. That means even if the content is visible, the user is not tied to it. The user keeps his identity hidden. That's the main purpose of Tor. It's the first one over here in a little diagram. It's something very important these days when we talk about network activity. People are very envious for their personal privacy, and as time goes on, we seem to have less and less of that, which can explain why Tor is such a popular platform these days. It also aids in hiding from authorities, which isn't, hopefully not its main goal, but it assists as well. And last but not least, we said not only does it hide the identity, but it also hides the content itself. It encrypts it, which isn't the main goal, but obviously it's a necessary mechanic to use in order to achieve anonymity, as we'll see shortly. Second main goal is censorship circumvention. As you may know, some countries or ISP wish to block certain content from their network for whatever reason there may be. Tor gives users the ability to escape those blocking mechanisms, be it by blocking the traffic itself or by blocking specific servers online. Tor has advanced techniques to avoid basically every blocking mechanism that's used today. We'll delve into it deeply later and how it works exactly, but just a brief overview for now. And the final purpose, and I'll say purpose in trademarks because it's not really a goal, it's more of a byproduct. When you give people the ability to be anonymous online and also escape any type of censorship and blocking on the internet, you can assume somebody's going to use it to do something illegal. The Tor network, the dark web, which we'll explain what it is later, is full of illegal activities such as trading weapons and drugs, which you may have heard of. Obviously, cyber activities, planning attacks, coordinating between hackers happens a lot. Data leaks that are being published are also usually spread around that network. And unfortunately, a rather shocking statistic is that 80% of the traffic turned out to be child pornography, which obviously is horrific, but this is the state of things. Illegal activity also includes much more. As you know, it's a broad subject, so we won't go into every single illegal thing happening over there. Before we talk about the actual technological concept and how it works, a quick history. As you can assume, what kind of body would need such an anonymous communication that's protected and secure and also has the means to build such a complex system? So you won't be surprised that it was developed by the US, specifically the Naval Research Lab back in the 90s, as a part of a program to help the Americans communicate online securely and anonymously without being traced. Around 2002-3, all the way to 2008, it was released to the public under the name of the Onion Router, or Tor. As we'll soon understand, the Tor concepts require a large user base. If it doesn't have a large user base, then it really can't give any anonymity, because if only a single entity uses Tor, let's say the United States, then whenever somebody will see Tor traffic, it will know it's the United States. So in order for the platform to have any strength as an anonymous communication tool, you must spread it around. And that's the main reason they decided to release it to the public. And finally, a quick status on how today looks like. Tor is very popular with 3 million users and passing around 250 gigabytes per second of traffic. It's actively researched in the academia and industry for obvious reasons. Obviously, improve the platform, make it more secure and faster and high performance. Also, from the other end of trying to break it, to de-anonymize the network and see how can we identify it and tackle with it. Most of the research is funded by US government agencies, as you can see. That was a quick overview. Now let's talk about how it actually works. The biggest idea and the main concept is called onion routing, which is very similar to many of you who may know VPNs. It takes the user traffics and it passes it on to a different server, which will handle the communication for him, thus distancing the user from whatever resource is trying to achieve. Tor takes this a step further. He uses 3 hops, 3 servers to pass through, that the user will go through a chain and pass through each one of them. And we have names for them. It's called an entry node, a relay node, and an exit node. The relay node is the middle node, and the other ones are pretty obvious. The user will basically send his traffic to each one of these servers in order, and only the exit node will eventually reach the resource at the end. And what's special about this is that the traffic is encrypted each time. So there's a few layers of encryption. That's why it's called onion routing, because you have layers of encryption. What does that mean? The user will establish symmetrical keys. For anybody who knows encryption knows what that means. If you don't, you can just assume that this allows the user to establish secured tunnels to each one of those servers. So he establishes symmetrical keys to make those secure tunnels, and then he can encrypt his data 3 times. If you'll take a look at this diagram here, you can see it easily. We have the message underneath everything, and then it will encrypt it once using the final server key, the exit node, and then with the middle node key, and then with the entry node key. So what happens is that the user encrypts it 3 times and sends it over to the entry node. Now, as we said, the entry node only has its own key, the first key, the last layer of encryption, so it can decrypt that last layer. The inside, the content within that layer, the entry node has no ability to see. So it will just pass it on in the chain and move it to the relay node, which will do the same, but remove its layer of encryption. And it will pass it on to the exit node, which will remove the last layer of encryption, revealing the actual content being transmitted, which could be encrypted or could be not encrypted, depending on what you do online. And finally, it will send it to the actual resource. And then in reverse, when the resource sends the response to the user, each one of those nodes will apply the encryption again. So the exit node will encrypt the traffic once, send it to the relay node, which will encrypt it again, the entry node, which will encrypt it one last time, and send it to the user. The user obviously has all the keys, so we can decrypt everything and see what the content was. So this is the main idea. Now you may ask yourself, what's so great about this technique? Why is it Why does it provide anonymity in such a strong, robust fashion? Well, this is because if you think about it, the entry node knows who the user is. It knows where the information, where the content was generated from, who's trying to surf. It can see its IP address. But the user has encrypted this content 3 times with different keys that the entry node cannot decrypt. So it has no idea what's being transmitted. It only sees where it comes from, and it knows it's going to send it to the relay node, which is also not the actual destination. The exit node knows where the content is destined to go to, which is the resource, and it may even be able to see the content itself if it's not encrypted, but it has no idea where it originated from because there were 2 servers, 2 hops before we got to the exit node. And the relay node basically just provides us with another layer of distancing between the resource and the user, so it will be more difficult to trace it back. You may ask yourself now, why won't we use 10 nodes or 20 nodes or as many as we want to make this even more secure and distanced? And the reason is of course performance. The more nodes you add, the slower everything is going to be. 3 nodes was basically found as the magic number for performance versus security, a known topic among technological topics in general. Another interesting point about this setup is that it's decentralized, which means we have no reliance on any specific entity. If you use a VPN, for example, which will also transfer your traffic to a specific server, you have to put your faith that the VPN doesn't do anything to your traffic. It doesn't log it, it doesn't scan it, it doesn't monitor it. You have to trust that the VPN is actually faithful to your privacy. In this setup, you don't have to put your trust in anyone. These nodes that we talk about that are spread around the world are ideally should be just other users of the Tor network. This is why we said the more users we have, the more robust the network. So you don't have to put your trust in anyone. They're not coordinated with each other. They're just random people like you. So nobody's writing logs on you. Nobody can monitor you. Maybe one of the nodes could, but it will not have access to the other nodes. So it will still be safe and secure. Also, no single point of failure, which is just generally good when you talk about networks, as opposed to a VPN, where if the VPN falls because of the server or something, then you have lost your network connection. Finally, a quick little side note, directory authorities. We won't go into everything about the Tor network in detail, obviously, because there's too much and we don't have enough time. But important thing to know about it is that all these nodes I talked about, you can think well, how does the user can find them? Where does he get them from? And they're public, and the answer is that public online repositories provide them to everybody who wants to see them. They're constantly updated and switched and refreshed. These are, as we said, just general people who want to set up a Tor node, a Tor server for themselves to provide other people with secure anonymous connection. So anybody can go and see them online and collect them. Okay, that's the general idea of how Tor works. Now let's talk a bit about what is the dark web. I'm going to take a quick sip of water to give you a second to look at this nice diagram that we got over here. Okay. So when we talk about the internet, there's the infrastructure of the internet, which is a physical infrastructure of servers, cables, radio, RF communication devices, and so on, which provide the transmission of data. But the actual content itself is being handled using protocols, obviously. So the surface web is the general known protocols, which you all may know. It's when you surf to Google or YouTube or Yahoo or CNN and all those nice websites. They're open to everybody who seeks to see them. But there's other terms like the deep web and dark web, which you may have heard. Let's organize them a bit. When we say deep web, we mean all the content online which can't be accessed without proper authorization. For example, everybody can surf into YouTube and see what's on there, but not everybody could surf, let's say, to your bank account. Only you can surf to your bank account because it's password protected. Even though the information is technically available online because you can get to it through any place in the network, only the person with the password can get to it actually and see it. That is most of the internet. If you think about it, actually makes sense that this makes the largest percentage of the actual content on the internet. This is the deep web. When we say dark web, we talk about networks that still use the same internet infrastructure as we said, but this time they use special software or protocols to make this communication. When we talk about regular browsers like Chrome, Firefox, or Internet Explorer, they use the general known agreed upon protocols like HTTP, HTTPS, and QUIC, names you may have heard. But when we talk about the dark web, it uses a different protocol, different language, if you will. So the regular Chrome browser or Firefox browser can communicate with servers that operate on this network, on this logical network that uses a different protocol. In order to be able to communicate with it, you have to have a designated browser that knows how to speak this protocol, this language, and that is the Tor browser. Another important term to know is onion services. When we talk about regular internet, as I keep saying regular internet, when I talk about Google, Yahoo, Bing, all these use regular services. It's server that use generic known HTTP service that you know how to talk to. When we talk about those hidden service that only the Tor browser can communicate with, we talk about onion services. When you surf to one of them online, it doesn't use the same known URL link that you may know. It uses something way less user-friendly. You can see here this gibberish, which is a hash of some content with a .onion in the end. As you can guess, these onion services as an onion routing are a perfect mix for illegal activities because it provides the user with anonymity, and also the onion service, I haven't said, we'll get to it in a second, is also hidden. It's hiding the actual content, the service provider. So the server itself can give people service and websites and web pages and everything, but you can't find its actual IP address. We'll talk about this in a second. So this is perfect for legal activities because you can transfer everything you want online, data, and buy and exchange goods that are illegal, and nobody can trace back, not the buyer, the user, and not the server which provides the service. But I still would like to say and point out that Tor does not immediately equal illegal activity. Tor is just a browser. The dark web is just a network. It can be set up to use regular websites like forums and everything that's perfectly legitimate. It's just that because all the illegal activities also tend to use this because of its anonymity capabilities, so it's got this bad reputation of a bad illegal dark net activity. Now we said onion services also want to be hidden. The server itself wants to be hidden because that's the whole point of the Tor network, for everyone to be anonymous. So how can a server be anonymous? When you talk about a server, you mean about somebody that's providing with you with information and service. You want to be able to talk with it. If I can't address someone because I don't know who they are, how can I talk with them? The solution to this question called Rendezvous Point. In the Rendezvous Point system that Tor developed, the server and the client will negotiate in a way we won't go into detail today, unfortunately, but anonymously we will negotiate some specific point node server in the Tor network, which will dynamically be generated and then discarded. It's not something permanent, which on it they will be able to exchange information. And they both will connect to that point anonymously. So if you look at this diagram, we have the laptop phone at top, which is the user, and then we have the server, not exactly, but for our intents, it's good enough. This is the server in the Tor network, and they both can connect to a specific rendezvous point. They both connect. You can see these little onion symbols. They represent the hops that you travel to the different servers. So they will transfer to them anonymously and get to the rendezvous point, which will exchange the information between the laptop or phone and the server, thus keeping them both anonymous and secure, but still being able to exchange data and traffic. I'll take this point to say that if you have any questions about what I just said, feel free to put it in the chat Q&A box, and I'll get to them in the end. The last thing I will talk about is censorship circumvention. As we said, some countries want to prevent access, either to stop illegal activities or maybe to stop things they consider illegal resources that they don't want people to access, like content or anything the government wants to do. So the default Tor network, the Tor protocol, is just a network protocol. It works differently, but it's not hidden. So when you use this Tor protocol, anybody who sees the traffic can recognize that this is Tor. Even if you will hide your, let's say somebody wants to block YouTube and you use Tor, so your traffic doesn't look like YouTube right now, it looks like Tor, So you pass the block, but the same person who blocked YouTube could just block Tor as well. He will say, well, I don't want Tor on my network because I know it's connected to illegal activities and I don't want that. So Tor came up with something new called pluggable transport. We'll talk them in the next slide, because it realizes that it could be easily blocked by blocking either the entry nodes we talked about, which are publicly available, or the protocol itself. There we go. Tor pluggable transports. This is the methods which Tor developed in order to suppress these, to evade these blocking mechanisms. These pluggable transports serve to basically hide the identity of Tor. So even if somebody sees your traffic, it can't be linked to you using the Tor network. How do they work? They basically color your traffic to look like something different. They pass it through a tunnel, usually, that makes it look like something else by whatever means they have. This cute little diagram shows that you can take any traffic and color it to be whatever you want. By coloring, you basically use some pluggable transports to make it look like something else. And the biggest pluggable transports used today are called MIC, Snowflake, and Bridges in combination with something called OBFS4. Let's talk quickly about these three pluggable transport to understand what it is they do. The first one, MIC, is rather simple. Instead of connecting to a Tor node, an entry node, and then surfing in the Tor network, you will simply connect to a Microsoft server, a CDN server. And that server will transfer your information, your traffic, then to the Tor network. What this does is basically if a government or an ISP wants to block this Tor traffic, this Tor node, or whatever they want to do, you will first log into Microsoft, which is perfectly legitimate. And afterwards, you will move on to whatever it is you want. And after the Microsoft server, you're outside of the ISP's control. So you can do whatever it is you want. This method isn't perfect, of course, because first of all, it costs money to use Microsoft servers, money that the Tor community doesn't necessarily have. And because of that, the performance isn't that great because using not a lot of servers to transfer so much traffic obviously will be very slow. Second technique is bridges and OBFS4. Those are kind of separate concepts that work together. So I'll explain them one by one. When we say bridges, we basically mean a Tor node, a regular Tor node, like the entry nodes we saw earlier, but this time they're hidden. These Tor nodes aren't publicly available. You can't index them. You can't find every single one of them and then block their IPs. The Tor community, the Tor managers keep them hidden in their own database, and they let them out sparsely to any user who seeks to escape blocking mechanism. So even if some ISP will try to index them by maybe pretending to be a user and requesting them, they won't be given all their nodes. They will give them a very small amount of them. So they won't be able to block everything. So they won't be able to keep up and truly control the network. Not only that, bridges are constantly refreshed and changed, and new ones come up and old ones fall down. So you can't really keep up with all the hidden bridges in order to actually block reliably. The second point is OBFS4 protocol. This is a protocol that's used to basically take whatever content, whatever traffic you have, and to pass it through a tunnel that makes it look like just regular internet traffic without any special characteristics that you can't tie down to say that this is Tor, because it just looks like something generic. It randomizes the content and encrypts it. It randomizes the size of the packets, and it randomizes the timing of the packets. So you can't really look at it and say this is Tor. So with combining the bridges to hide and use IPs that can be blocked, and the OBFS4 that hides the known patterns of how Tor works, you can quite effectively escape most, if not all, blocking mechanisms. And the final pluggable transport called Snowflake, it sort of combines these last two things together. It uses what's called Snowflake proxies, which are very similar to bridges or just general nodes, but instead of being difficult to set up and require an actual server, anyone can just set up one of these Snowflake proxies by surfing to a specific web page using a special technology called WebRTC, which is a very clever protocol which lets you set up a server that can be communicated with and found through the internet without having a public IP, without running anything on your machine, just surfing to some specific online web page, and it will be able to run it on your browser. So these proxies are generated very quickly, very easily by anyone who wants to. And then every single Tor user can request these proxies by communicating to some other server which provides that information using domain fronting. So you kind of combine the best of both worlds in here, where you use domain fronting, but don't pass all the traffic through it. So it's not as slow. You only request the actual server, and you use these very quickly set up nodes that can be easily indexed and then blocked using their IPs like regular nodes. That's the end of my part. I will pass the mic back on to Orna. Thank you.
Thank you, Dror. Very interesting and comprehensive. I would like now to provide a short intro to Allot, and then we'll continue to see how our DPI technology helps to overcome the challenges that were mentioned by Dror. Dror, click. Thank you. So Allot is a global provider of leading traffic intelligence and security solutions. We are active in two main markets: the telecom markets, communication service providers, and at the enterprise, we actually approach all types of enterprises from various industry verticals and in all sizes. We have a very big install base of hundreds of communication service providers and more than thousands enterprises worldwide. We have global presence of offices around the world. We are traded in NASDAQ. Our revenues in 2021 were 143 million, and we have very strong balance sheet. And actually, at the last 2.5 decades, we invest the best of our R&D efforts and time in actually being in line in the network, understanding everything that goes in and out, of course, without affecting and impacting the network performance. And by that, we enable we provide our customers with leading traffic intelligence solutions, as well as we protect their networks and their end users. The Allot Smart is actually the line of solutions which is dedicated for the telecom industry. You can see here at the left part of the slide, just a subset of our very broad set of CSP customers. We are deployed in mega tier 1 networks, communication service providers with very high throughput, and hence we provide multi-tenancy capabilities, and we ensure the quality of experience and the quality of service of the end users of the network. We are already deployed also on 5G networks with virtual cloud native and virtual additions, and we actually deploy advanced AI technologies based on patterns and signature identifications, which you know to classify and understand the ongoing traffic. At the enterprise, this is, as I mentioned, we have more than 1,000 enterprise customers worldwide in various industry verticals. You can see here just selected logos from our broad customer base, from our 4 main verticals, which are the last 2 years under our focus, which is the public sector, the financial sector, the higher education, and the technology and manufacturing sector. I want now to actually provide a short overview of the main key capabilities of our DPI technology and actually connect it to the content that we just heard by Dror. So our next generation DPI engine is dynamic application recognition technology. And as we said, it sits inline in the network. It is capable of identifying and analyzing encrypted traffic. And this is the nature of the traffic that Dror spoke about, and risky applications. It's based on patterns recognitions and signatures of application. Therefore, we do not need to do any SSL deep inspections. And actually, we bring our really domain expertise of more than 20 years at the field. We can actually identify today more than 1,000 applications. We have a dedicated team of science researchers which actually invest their time and effort to identify more and more applications, to produce more and more signatures, and we update our customers regularly. We actually use machine learning and AI techniques to identify this type of traffic. And I want to emphasize that all the modes of operations that were mentioned by Dror can be monitored, can be identified by our DPI technology and can be controlled. The most important thing is that we provide our customers with the regular bi-weekly updates with the most updated application packs and protocol packs. In addition, we actually provide very comprehensive decision-making BI tools. You can see here an example of performance dashboards for the IT manager, in which you can understand the QE score of the end users, the inbound and outbound traffic, which applications are in use, which application domains, who are the heavy users of the network, the inbound and outbound traffic during peak hours. And actually all these comprehensive reporting and information help IT managers in the network understand which applications they should block, which application they should prioritize, and how they need to define the policy rules of the network in order to assure high quality of experience for the end users. So I think we have time now for questions, right, Dror? And I see here there is one question at the chat, so you can let's look on it.
So yeah, I'm being asked, are there more applications similar to Tor? So when you talk about Tor, we're actually the main technological concept of onion routing, of encrypting several times and passing through different servers. Yes, that's used in other areas, though the biggest network that actually used today using this technology is the Tor network. The Tor network itself isn't a specific application. You can connect to it through different methods. There's the Tor browser. There are a couple of apps, known apps for the Android and iOS, which can be used to communicate with it. There are services which know how to direct all the traffic of your computer, not just the browser application that can direct all the traffic to the Tor network, thus making all of your traffic encrypted and anonymous, not just your browser surfing. Let's see, I see another question. Can you use Tor browser to surf regular sites like CNN.com? Yes, there shouldn't be any problem with this. Tor is a regular browser. It knows how to speak the known common protocols like HTTP and HTTPS. What's special about it is that it can be used as well to talk with other protocols which are designed for anonymous activity. Let's see another question. Can Allot detect all Tor traffic, including the obfuscation mentioned? Yes, today we have solutions to all the different modes described here and a few more that weren't described here. Let's see if there's any other questions. Give it another minute. Okay, I see one more question. What if someone controls most of the Tor nodes network? Can he de-anonymize users? Okay, what if somebody controls, let's say, most, if not all, of the Tor nodes that are in the network? Yes, it has been proven that you can link and correlate traffic between the exit node and the entry nodes and the middle nodes to help you understand and trace back who the user was that served to a specific resource. It actually has happened in the past that attackers have tried to flood the network and create a bunch of their own nodes and controlled about 30 to 50% of the network, and were able to trace down a lot of the users. Tor is constantly trying to develop new ways and ideas to fight against this kind of de-anonymization strategy by making the randomized nodes that build your own basically route into the network be chosen in such ways that even if you control a substantial amount of the network, it will still be difficult to trace down users. There are a few more questions. I'm just going to go through them quickly.
Yeah, there is a question here about detecting the VPN traffic, the VPN proxies. Who can detect this traffic?
Can Allot detect VPN and other encrypted traffic? Yes, that's one of the main things we do in the DPI team, which is develop ways to identify basically every traffic we want. And as Orna stated earlier, we support currently today more than 1,000 applications. Many of them are VPNs and encrypted traffic as well that we can identify. How can Allot help identify Tor connections? We have our own, as you can guess, intellectual property that we developed strategies to deal with these advanced obfuscation methods, which unfortunately I can't discuss here because it's company property and obviously it needs to remain secret. Okay, I see there aren't any questions.
Okay.
Thank you very much, everyone.
Thank you. Thank you for the feedback, and thank you everyone for attending this webinar indeed. Thank you, Dror. It was really interesting. And see you all, stay healthy and safe, and see you all on our next webinars. Goodbye.
Goodbye, everyone.
Goodbye.